So now, today we are discussing about first order logic, and in the first order logic, we are going to discuss about inference rule. Okay. So now, in the previous section, we can discuss about prepositional logic, and same we can discuss about the inference rule. Okay. So same here, but different. The first order logic inference rule. Okay. These are very important because the knowledge based student can work on these two types, propositional inference logic and first order inference logic. So we are discussing about inference logic. Inference in first order, FOL, that means the first order logic. So that is the short form of FOL. So first order logic, FOL. Okay. The first one is comes inside inference rule for the first order logic is substitution. So that means we have to substitute the value of premises. Okay. Suppose how can represent the now a complex sentence is given, then we have to replace with a smaller one. That smaller one can represent as a same as a bigger one. So that is the process we have to follow in the substitution. Okay. So what we have to do? Suppose we have to substitute this one. So f of that is the f that means indicate that first order logic can be substituted with a slash x. Okay. So what is the meaning of that one? A slash x. That is the rule for the substitution. So that means in place of in sorry in place of x, it will be updated by a. Okay, that means where x is present, then we can represent as a, where a is a constant terms. Okay, now suppose here x represented some set. अगर x कोई सम सेट को रिप्रेजेंट करता है, that means it represents set, so a is also represent that set. So that is the meaning. That means a large quantity, a large complex sentence can be replaced with a constant name like A, B, C, D. That is called the substitution value. So whatever the meaning of that one, suppose this is the meaning. So whatever the meaning of that means semantic meaning. I'm talking about the semantic meaning. Whatever the semantic value of X is same as a semantic value of A. Semantic value of A. So both value are equal. So whatever A is refer, so X is also refer. So that is the process of substitution in reference inference in first order logic. Okay. So this one. So next one we can use the equality. So equality, that means we have to prove the two different object. I'm talking about in equality, we can talking about the object. Okay, object may be a name, or maybe a constant value, or maybe a digit. Everything will be object. Suppose I can define a relation like a father. Father, that is a relation. I can here write ak and is equal to, I'm going to write just like a mk. So that means who is the father of AK is also the father of MK. That is the meaning. That is the equality relation in first order logic. Okay. So both now see these both are interrelated. So both are related. That means maybe these are the brother. Okay. So both are the brother. That means same father. That is the possibility. So that is the meaning of inference. So that's why you are writing equality sign. The father of AK is equal to MK. That means because M and K both are related to brother. Both AK and MK are brother. So these are the things. So what is this one? So as you know, so this one is the relation, and this one is the object one, and this one is also object two. Okay. So these things are there for the equality. So substitution, equality, then we have to find out some inference rule. So now, first one is called universal generalization rule. Okay, in the inference rule, first one is called universal generalization universal generalization rule. Okay, so what is the meaning of generalization? So when we are talking about the universal, that means we are talking about the whole world. Okay, now we can see the Venn diagram. So now see, this is the the Venn diagram. So suppose this is the universal set. So whatever the value inside that one lie, we can create a generalization rule. Suppose here A is present, B is present, C, D, E, and F. So in that box, that universal set, A, B, C, D, E, F are the present, and both having a different meaning, both having a different quantity, both having a different object. But we have to create a one rule, that means both that rule they can interlink to each other. तो हमें एक ऐसा रूल क्रिएट करना है कि जो आपस में कनेक्ट हो. तो इसके लिए हम लोग क्या करते हैं? सो वी हैव टू क्रिएट अ प्रीमाइसेस. सो व्हाट इज द मीनिंग ऑफ प्रीमाइसेस? The one word premises. Okay, premises. So I can take our premises of probability of P and C. That means we have to check, we have to take a one constant arbitrary function C that belongs to both. सो दैट इज दैट इज कॉल्ड द यूनिवर्सल जनरलाइजेशन. कि हमें भाई एक ऐसा सी क्रिएट किया जो सारे ए बी सी डी ई और एफ को रिलेट करता हो. सो दैट इज कॉल्ड द यूनिवर्सल जनरलाइजेशन रूल. एंड पीसी इज कॉल्ड एज अ प्रीमाइसेस. कि हमने एक प्रीमाइसेस किया, एक एरिया क्रिएट किया विद इन दैट एरिया. सो दैट इज कॉल्ड. सो वी कैन रिप्रेजेंट एज अ whole value of PC, that means PC is belong to the whole value of X of PX. That means for all value of X, PC is exists. That means C is exist. That means whatever the value of C is C, X. So that is a one type of substitution कि हमने X को C के साथ replace कर दिया. And we can define the universal generalization. Okay, and X should not be, now see, we can study in a previous class free variable and bounded variable. So X should be a bounded, it cannot be free, not a free. ये आपका free variable नहीं होना चाहिए, ये आपका bounded variable होना चाहिए. That means we have to write like this one. So suppose if writing P of C, and if I am writing like that one, so this is the wrong. Okay, because here X is a free variable, not a bounded variable. So that's why we have to write in the place of X, I am writing the generalization rule for all value of Y, P of Y is it, like this one. So this one is the truth. Okay, ये समझ में आया? Universal generalization rule in a first order logic was similar to है, that is a similar to like a union, intersection, disjunctions, negations, both are all are similar, but representation is totally different. Because when we discuss about the first order logic, then we are discuss about like universal constant for all, existential constant for all. So these things are we can use. So next one is rule is called universal instantiation. Okay, universal instantiation. So second one is called universal instantiation. Okay, universal instantiations, that is called. So what is the meaning of that one? So first understand. So this is called the valid inference rule. The meaning of instantiations. So instant we can define the rule on the previous one output. That means अगर आपके पास कोई previous knowledge है, that means we have a knowledge about the previous one. So on the basis of we can conclude the session, that is called instantiation. So now when the workshop is going on and after the end of the workshop, we can derive the conclusion whatever I deliver inside the during the workshop. So that is called the instantiation universal. कि हमने जो वर्कशॉप दे दिया 2 घंटे का, उसे हमने बस 1 मिनट या 2 मिनट में कंक्लूजन किया. सो दैट इज कॉल्ड इंस्टेंटिएशन. Okay, so that is the meaning of instantiation. So instantiations can be represented using the substitutions object. Okay, so we can represent as a, for all value of x, px can be represented as a c. That means here also, that is the opposite of generalization rule. हमारे पास क्या था, अब देखो generalization में क्या था. जनरलाइजेशन दैट मीन्स वी कैन गो फॉर बॉटम टू टॉप. दैट मीन्स हमारे पास बहुत सारा ऑब्जेक्ट था. आई हैव अ डिफरेंट डिफरेंट टाइप ऑफ सेट. देन वी हैव टू क्रिएट वन लॉजिक. दैट मीन्स बॉटम टू टॉप, bottom to top. But instantiation, we have to top to bottom. Now different different things, and we have to conclude one small thing. So that is the top to bottom. So that is a universal instantiation. Okay, so that is the difference between the generalization rule and universal instantiation rule. Okay, so these things are we can define. Is it clear? So now when instantiation use, we can add multiple. Now see here, this is the one statement, this is the second statement, this is the third statement. So we can add a multiple statement to conclude a single one statement on the basis of the previous knowledge. Is it clear? Yeah, anyone please reply. Universal instantiation, that is a clear now? Okay. Now, the next one, suppose I'm going to write, suppose I'm going to write give one example of the universal instantiation. Suppose for all x. Now, so everyone like cricket in this world. Everyone like cricket in this world. Okay. So what is the meaning of like? Suppose I can take. So I can take one example. So suppose I'm writing everyone. Okay, and everyone denoted as a x. Then what is the x? The x may be a male, female, everything can calculate. Everyone likes cricket. cricket. Okay, cricket. Now suppose I'm writing ki Sita is like cricket, so that is the instantaneous universal. That means Sita belong to that universal constant. Sorry, universal instantaneous. That is x. So on the basis of we can derive. Okay, so this is the way we have to use the universal instantaneous and universal generalization. Okay. Now, so famous example we can say that one example is all king who are greedy are evil. So that is a famous example. Every book is follow this one. All kings who are greedy are evil. So how this can be represented as a first form FOL, that is important. Now suppose I can denote x as a all king, so I can write for all king. Okay, so I am writing a king as a function of x. That means here a king denote x. The x may be any person like a Maharana Pratap, anything. Okay, Maharana Pratap, Chandragupta Maurya, Akbar, these are the king. So X can represent Maharana Pratap, maybe Akbar, maybe Shah Jahan, maybe Begum Hazrat Mahal, maybe like that one, king. So we can define for all king, those who are greedy. That means here we can use the, what is the meaning? Conjunction. So we can use a conjunction because greedy and evil both. So we have to write a greedy. So greedy is another quantity, so I can put y, and implication, this one is a true when evil. So who is the evil? So king is the evil. So I am writing x. So this is the way we have to write a first order logic. A given sentence is given, then how the first order logic we can define. Okay, so this way we have to write. Now see, here suppose I am writing Akbar AK. So here we have to no change. We have to no change as it is y, but here we have to change AK. Okay, so this is the universal instantiation. ओके, सो यहाँ पर किंग एक बहुत बड़ा यूनिवर्सल सेट को डिनोट करता है, उसके बेसिस पे हम वी हैव टू डिफाइन ऑल द थिंग्स. सो नेक्स्ट वन एग्जिस्टनल इंस्टेंटिएशन हम लोग डिस्कस करने वाले हैं. थर्ड वन, सॉरी, एग्जिस्ट EXIS existential, okay, existential instantiation. Existential instantiation, that is the scale. This may be of from different type, or I can expel existential instantiation. Okay, so now what is the meaning of it? So we have to eliminate a previous one knowledge and to add the new one knowledge, and we have to prove that is the true. Okay, अगर आपके पास पहले से कोई डाटा है, उसमें से उस डेटा में से कुछ को एलिमिनेशन करना है, और उसके बाद we have to add some inference rule, and then we have to prove this is a true. That is called existential instantiation. That means we have a instantiation that is called existential elimination. Okay, existential elimination. So we can say that existential elimination. Elimination, which is valid inference, जो आपका valid inference rule in a first order, which is valid inference, which is the valid inference rule in FOL. That is a valid inference rule in FOL. Okay, so now existential instantaneous, how to represent as of. So that is means so some point is also important. So when knowledge based resident is whatever is not logically equivalent to the old one, so that is important. So we can write also that point. So new KB knowledge based, whatever the inference we have to write is not logically equivalent to old KB. What is the logically equivalent? That means the truth table should be same. That is the meaning of the logically equivalent. Okay, but it is a satisfiable if old KB adds satisfiable. So what is the meaning of satisfiable? Satisfy. Okay, so that is means satisfiable, that means all true. Okay, that means all true, so that is true. Okay, but it is satisfiable if old KB are satisfiable. That means this is the true, this is the true if this one is the true, old KB is the true. अगर आपका नॉलेज बेस्ड ओल्ड KB एजेंट इज ट्रू है तो न्यू वाला भी ट्रू होगा. दैट इज द मीनिंग ऑफ दैट वन. Okay, so we can write a represent as a there exists some value of x and where we have to derive a one constant c. So existential instantiation we can define there exists some x. Okay, that means we have to eliminate some x with the help of that c. That is the meaning of that. So c is a true. Okay, so this is the meaning. So now see one example. So king and crown. So these are the famous examples. There is a sum x, so that is represented as a crown. Okay, so crown as a x. So who will wear a crown? A king. And king where we are on head of king, and we can inference as a head of a king, and we have to write among all king we have to write a Akbar. So that is the meaning of that. Okay, that means the king here. What is the we can replace king? King will be replaced by the crown. King will be the replaced by the crown. Okay, now see. So king and crown both are true. That means old KB agent having the king, but now KB agent is using a crown. अगर हम बात करें ओल्ड की, तो आप क्राउन की जगह केबी की जगह किंग भी लिख सकते हो. दैट इज कॉल्ड ओल्ड. अगर इसकी जगह न्यू के भी बनाना चाहें हम लोग, दैट मीन नॉलेज बेस्ड, सो आई एम गोइंग टू राइट अ क्राउन. तो ये क्राउन हो गया. तो किंग हो या क्राउन हो, जो किंग होगा वही क्राउन पहनेगा. और कहाँ पहनेगा? ऑन द हेड. सो आई कैन राइट एक्स कॉमा अकबर और एक्स कॉमा एनीथिंग लाइक शाहजहां, शेरशाह सूरी, मे बी पॉसिबल. So I can write there exists some x. So therefore exists some x. Those who wear a crown on a head is named as a Akbar. Okay, so that is the meaning of the existential instantiation. Okay, so now the last one. So last one is called as a same existential introduction. Introduction. Okay, so what is the meaning of existential introduction? Is known as a generalization, which is a valid inference rule in a first order logic. अगर हम बात करें एग्जिस्टेंशनल इंट्रोडक्शंस का, तो ये जनरलाइजेशन टर्म है जो फर्स्ट ऑर्डर लॉजिक में हमेशा ट्रू होता है. Okay, so now, so this is the existential. That means there exists some x. So now this is the opposite of that one. So we can write a P of C. P of C is there exist x like that one. So हमने क्या लिखा? ये जनरलाइजेशन टर्म है. Now see the first one. यहाँ now see, when we're talking about the generalization, so like this one. So similar to the existential instantaneous, that means instantaneous introduction is also like some similar. Okay, so we can generalization terms we can write that. So this one is called as a existential generalization. Okay, generalization. Okay, existential generalization. That is the meaning of that. So these are the things for the inference rule for the first order logic. So what we have discussed, we have to discuss about the universal generalization, then universal instantiation, then third one existential instantiation, and the fourth one existential introduction. Okay, so these are the inference rule on the basis of knowledge based agent can be worked. So that is the way we have to define a KB. So this is the way we have to define a KB. Now, what we have to left? We have to left with a conceptual graph, then unification we have discussed about, then we have to go for the reasoning part. Then we have to discuss about inductive reasoning and deductive reasoning. Basically, they will ask the difference between what is the difference between inductive reasoning and inductive reasoning and deductive reasoning. Then what is the resolution? What is the unification? So before study the unification, we have to understand the concept of the substitution, because what happened in unification, we have to two different logical atomic expression identically by finding a substitution. That means हमें दो different atomic expression को आइडेंटिकली वी हैव टू फाइंड टू सब्स्टिट्यूट्स. मतलब हमारे पास दो सेट हैं, set 1 and set 2, set A and set B, and both set having the replacing value has a x. So हमें we have to find out the identical value of x that can be represented as a also, it can also represented as a b also. That is called the unification. Okay, so unification we can explain with the help of first order logic substitution. That is the way. Okay, so we can take a two literal in an input and make the identical using substitution. That means literal. What is the meaning of literal here? That means we have to use a two constant. That is the meaning of the literal. Okay, literal. So we have to use a two constant. Literal, that means the meaning of constant. So we can use anything like a psi. So we can use here psi 1 and psi 2. Okay, so this one psi 1 and psi 2, and try to make it as a equal. Try to make it as a equal, and on the basis of we can define the different things. Okay, so now this is the way we have to represent the unification. So don't worry, we can go for the detail of unification. Then how can find out the unification? What is the condition for the unification? And then implementation of the algorithm of unification. Then we have to go for the uh, which one? Next topic will be your reasoning in AI. That means we can discuss about inductive and uh, deductive reasoning. Then we have to discuss conceptual graph. The conceptual graph is very easy. We already study in the lot of graph like informed search, informed search, uninformed search. We can discuss about lot of things in a graph. Now see, what is the conceptual graph? Suppose we are talking about. So now, whatever you are writing in a first order logic, this all logic can put inside a rectangle box, and we have to inherit it one by one to get a output that is called the conceptual graph. बस आपको करना कुछ नहीं है, बस आपको रैपिंग करना है कि आपके पास कोई ऑब्जेक्ट है और वो ऑब्जेक्ट ऐसे है बिना बॉक्स का है, उस बॉक्स में रैपर कर दो और उसे सही जगह पे डिलीवर कर दो. दैट इज कॉल्ड द कॉन्सेप्चुअल ग्राफ. अगर हम रियल लाइफ की बात करें, अगर आप किसी भी चीज कहीं भी मार्केट से आप कुछ भी चीज खरीदते हैं, तो क्या होता है, अगर मैं ऐसे चीजों को दे दूँ हैंड टू हैंड, सो दैट इज नो मीनिंग. सो वी हैव टू मेक इट अ सेंस, वी हैव टू मेक इट दैट इज फील very special, and you feel that this value, this object is very special for you, and this is the new for you, so we have to wrap up that box. Okay, like when we are giving to the gift to the friend, so those things are comes inside the conceptual graph. So whatever you're writing in the logic in a sentence in a simple way, we have to put inside the box and get the output. So that is the meaning of the conceptual graph. Is it okay? Okay. So unification. So little bit I can discuss here. So I'm going to write unification. So what is the unification? So it is process of making. It is a process of making two different logic. I'm talking about the atomic. So here the logic is atomic, not a complex compound. Okay, logic atomic expression identical by finding a substitution. Okay, so that is good. So we can say that it depend on substitution process. So it depend on substitution process. Okay, so that is the meaning. So this is the definition of unification. Maybe they will ask you in the one marks. So what is the unification? So we can write it is the process of making two different logic, basically atomic expression identically by finding a substitution dependable substitution methods. Okay. So you can write we can take two literals. We can also write we can take two literals as an input and make it as identical using substitution. So here we can use two literal as an input and make it equal by substitution. Make it equal by substitution. Okay. So this is the meaning of that one. So make it equal by substitution. Okay. So basically, how to write this definition? So you can write a unification UNIF. That is a capital. All the things are capital. Unification. We have to use psi of 1, comma psi of 2. This is the one. Okay. So that is the way we have to represent the unification. Unification UNIFY, and we can represent psi of 1, comma psi of 2. So this is the two important points we have to describe. Okay. So that is the unification. So later on in the next class, we'll discuss about lot of things on the unification. Then logic, reasoning in AI. Then your unit is finished. That much. Okay. Then from the next week, we are going to start a machine learning. So that is an introductory part for you. And I think you are already a study in a fifth semester or sixth semester ML. So that is very easy to you. Okay. And after machine learning, the last topic, maybe remaining a prologue. So prologue is very easy. I think you can handle all the things. So Vivek, yeah, Vivek, you did not send me the study attendance list. Okay, like 8th of September. Did not send. Okay, did you send? I will check. Okay, okay. Huh, I got it. Okay. So for today, you can send me. Okay. So now your class is over. May we leave. Thank you.